Hello, I'm Álvaro Calafell, and in this fourth video I'm going to explain how the harmonic distortion is calculated. In the first video I introduced power quality, the concept of harmonics and their origin. We studied that this origin comes from nonlinear loads that inject harmonic currents in networks. When these harmonic currents go through a network impedance, they cause harmonic voltages. We will now determine if the currents and voltages are highly or lowly distorted, and what is the level of this distortion. In order to do this, we have two ratios, the individual harmonic distortion and the total harmonic distortion. Let's say we have a current and a voltage which are distorted, with the fundamental waveform and the harmonics. The individual harmonic distortion is determined for each harmonic, and it's the ratio between the corresponding root mean square value of the harmonics and the root mean square value of the fundamental waveform. This ratio provides an insight about the weight of harmonics on the waveform distortion. The total harmonic distortion is a global ratio about the waveform pollution, and it is determined as the ratio between the square root of the sum of the squares of all the harmonics divided by the root mean square value of the fundamental waveform. These two ratios can be applied to characterize the distortion of the current, as well as the voltage. To determine the distortion of the currents, it is useful to know the quality of a nonlinear device. If the distortions are greater than 10%, the device is a very pollutant load. Determining the distortion of the voltages is very useful to know the quality of the voltage in the point of common coupling. If the distortions of the voltages are greater than 5%, the voltage waveform received is very polluted. To illustrate this, the following example will be analyzed. We have the distorted voltage with the root mean square value of the fundamental and the harmonics in the table. I would like to determine the degree of distortion of this voltage. First, the individual harmonic distortion of each harmonic are calculated by dividing the root mean square value of the harmonics by the root mean square value of the fundamental waveform. These results are shown in the following tables and bar plots. These could be compared with the standard limits to verify the level of distortion of the voltage waveform. We could also determine the total harmonic distortion. To do this, the root mean square value of the harmonics is calculated and divided by the root mean square value of the fundamental waveform. Once again, the results can be presented in a bar plot as well as a table to compare them with the standard limits to verify the level of the global distortion. Both indexes are necessary to analyze the distortion. For instance, let's take the following example. Imagine we have a voltage waveform with the data in the table, and we want to determine the distortions of the waveform. The total harmonic distortion shows that the waveform is highly distorted, and the individual harmonic distortion indicates where the distortion is originated. In this case, the voltage is globally distorted due to the third harmonic distortion. In this new case, if we look at each individual harmonic distortion, they are all found under 5% and thus correct. However, the total harmonic distortion indicates that the global waveform is distorted. This is due to the contribution of each harmonic. In conclusion, we can have a distorted waveform due to a specific harmonic or due to the contribution of all the harmonics. To complete the video about the calculation of the harmonic distortions, I'm going to provide you with a script in MATLAB code to determine the individual harmonic distortion and the total harmonic distortion. To the left, we have both definitions. As for the script, first, the program reads the data of the waveform and accommodates it in two arrays, one being time and one being voltage. After that, the Fourier transform of the waveform is obtained and the root mean square value of the waveform is determined, which in this case is voltage. Once the root mean square value of the fundamental and the harmonics is calculated, the expressions to determine the individual and total harmonic distortions are applied. At last, the individual harmonic distortion is plotted in a bar figure.